our device, the Microcolor, which is a color separator device. Our project members, the program designer, Gabriel Cortabarrio, who is here, the gentleman on the right. Chief Assembly Engineer, which is Julio Garcia, and myself, Alex Galindo, project manager. For our project's objective, we're going to design a factory setting environment conveyor belt that separates specific objects based on color. Our function, it would allocate the desired part or object into a designated bin, which will be here in any case for the actuator functions.
Basic theory operation. The sensor can detect in the conveyor belt the object. The color sensor scan the color will pass here. If the color matches the things that we program on this one, the conveyor belt continue with the part stuff that we put it with the color. If yes, the color read the color sensor, the color, and then send the sign here, and then here at home and push the things that the color sign we program.
Okay. I'm going to talk about the PLC model we use. We use the Microcolor 1000. These numbers are very important because the number 10, you see, it means how many input and output together have the unit. In this case, have 6 input and 4 outputs. So 6 plus 4, the 10 that you see here. Then the B means the input. The input is in DC. This is the letter B. The W means the relay, the user. And the A is very important because it's the output you can use by relay, also DC or DC. So it's very comfortable.
This can for running too, right?
Yeah. Yeah. You can see it's protected. You have the unit very small, comparable with the old units.
Okay, we are talking about now the sensor. This is a color sign for electric sensor. This is 45 CIR, and the cable is a 889 DC control set, batch back port. Okay, the sensor, this one, the project name is small because it's the sensor color. If you see the project is called color Microcolor separator device, because this one can read multiple colors. Have 3 inputs, and you can put it 3 different colors to separate it. And then, in this case, we're going to use only one color, because for this PLC work, we need other PLCs. The name is Microcolor 1400, and we have right now a Microcolor 1000. With this PLC, we can use only one color. For that reason, because the other one is analog PLC, and this one not. And then read only one color, and we have only one actuator. If we have it before, the other PLC supposed to be was 3 actuators to read 3 different colors and push 3 different figures.
So let me ask you a question. So the sensor is the price, 629 is the price for the sensor itself?
Yeah,
Yes.
that's it's very expensive.
Expensive project.
You guys buy that? You want it? Still would. You want it or you buy it?
No, we buy.
Okay. Still would, right?
Okay, this is the cable for the interface. The cable is a special cable, looks like a similar cable you can find in the computer store, but it's different. This is the high density cable. So this is why the price is high. And this interface, we can use the both. And the 232, RS232 and 4 85 in the version for using the LAN. And this is the actuators. The actuators work like a solenoid. The principle of the solenoid is a coil. The power is 110 volts, and it works with the solenoid. Open the valve and they pass the air. This is why we have a compressor there, and it's put there.
Okay, the motor that moves the conveyor belt is a DC motor, 24 volt, 600 RPM, 0.5 millions. And this one is static. We use the static to supply current to the motor because this one is DC 4 and have 900 amps to support the motor. This is the pulley here to move together with the conveyor, with the pulley, with the motor, and we use the U-belt to move the conveyor. And this was the air compressor we got 100 psi. This is for supply the air to the tray.
This is what we used to assemble the PLC in the back of our project, which if you can later after the presentation you can see and take a look in the back. We use our D-mounting channel and the terminal blocks to connect everything together. Later on you can actually take a look if you want. Next slide. This is our conveyor belt, which our engineer here built by himself, made out of wood. The belt itself is made out of PVC material. It has some pulleys and some metal rods here. You can see. This is our prices for the project. As you can see, it's a really expensive project. Even if you see it's just like a demo, but it's like we said previously, it's a factory setting type of project, which you can like Julio said, you can use more actuators or PLCs to create a really fast environment in a factory for moving materials.
This is the flow chart example. So here start, the motor will start, and then have a no and yes. If not, the conveyor spools the oil, stretch, drops. If yes, check the processor color design here and activate timer in the PLC program, and the actuator spools the oil there.
This is another component that we use, like Julio said, power supply that we have just in case, that we have right there. In case we didn't want to use the car starter, which was a better option, we just have it just in case. It's a 130 VAC and output 13.5, since we only need 12 volts and 16 amp, which is plenty enough energy. That's our switches. We have two switches. This is the power light switch here, which turns on the PLC and the rest of the components, like I told you previously, on the connected in the back of the PLC. And the other switch, which is a power switch independently, which this one just turns on the motor, which gives where it gets the power from the starter. So this one, when we turn it on, the belt starts moving by itself.
This is a brief design about the dimensions, about what you see here. The motor that is working, the motor is with 24 volts VDC, but actually we're using 12 volts bulb with this. And this is the sensor you saw here, very small. It's connected to the PLC. This is the connection here. And this is the actuator, this connection with air to the compressor. And also have electrical connection to the PLC also, to the output, use only one output. This is the electrical diagram. We use, this is all the inputs, and this is the output. In the input, we use the submit connection. The submit connection means the negative you connect to the common, and the positive here for the sensor. But there is another connection, like a surge connection, that is the opposite, connected the positive to the common and the negative to the sensor. But it's different, especially when you use analog input, analog sensors. But in this case, we use the submit connection, and this is the output. When the program passes the sensor detect here, close the circuit, and then work the ladder, the logic ladder, make the program, all the timer, everything, and then goes to by the relay internal, goes to the circuit here, 110 volts, and then work the actuator. This is the logic ladder made by the program. There is logic 500, and this is the very simple area with you can see here. This is the presence of the sensor. When detect the color, it's close here. When it's close here, energize this one. Then close this. This is only second, fraction of a second. Then this is open again, but this is connected. When this is connected, they close this one also. When this is connected, the timer is working. This timer is the time from here to here. We put at the beginning 5 seconds, but then I had to put 2.46 seconds, exactly from here to here. It's very important the speed of the conveyor for that. But when I see this is working, and then we just got the time, 2.46 seconds, then close these two at the same time. This one, open this valve. And this is what you saw, the air coming. But then, work this one also, 2 seconds. This 2 seconds is the time this open. You need time for the air open and then close. When you got this 2 seconds, open this. That is normally closed. When open this, everything back to the initial point, and then close it.
So what color is that one registered
right now? Actually, we programming for detect yellow.
Yellow
color.
Yeah. Now, I got a question. Will that detect all variances of yellow? Because there's all types.
It
of
does
yellow.
have a range.
Yeah.
That's why the sensor is really expensive. It has a really high quality, and it does have a range.
It will detect different shades of yellow. when it
Yeah,
comes
because
out.
you teach at the
teach
sensor.
the
You
sensor.
teach with the color.
Yeah.
Teach, and the sensor is like recognize that color and keep in his memory. It's
It
about
has a range also.
the colors,
It's
have
specific
different
colors.
frequencies.
Yeah.
Every color has a different frequencies. This is why we use only one color, because this is more used for the analog PLC. For the PLC that have input in analog, not like this. This is a PLC with a discrete input. So that means yes or not.
Yeah.
So in this case, we only use this one. We can put with more colors, but
Yeah.
we can work with the PLC. You know?
Okay. All right. One more question.
Demonstration time.
Where would you implement the system?
In factories, like we said in the previous, for reading bottles, if you want to read by size or by specific colors,
Food.
separators, food, it depends. Showing my daughter has for all the applications, so you can use a PLC and a sensor. It's mostly like a factory type of.
Like if you have different colors going to different vendors, then that way you can package it.
So
If not,
usually it
it'll
says
keep
here
on.
the applications you have for
Yeah.
material handling, packaging, food processing, and even transportation. They use it.
Yeah, because the fruit, change the color.
Yeah.
The lemon or yellow or green.
Yeah.
Maybe the sensor works
It's the labels which they put on the box and
also. Yeah.
Just by the fact of reading a color, you can either put something like we're demonstrating here. Like we can put something in a bin, like separate it, or just move it down the conveyor belt, for packaging and others. Like, so, the uses are up to whatever
Yeah.
the people actually making those.
That's right. And that only shoots out air? It doesn't stick out like a stick or anything?
Yeah, it does. Actually, it does. It pushes out. You'll see it. It pushes out a little pin, and it retreats after that. Like he said, for 2 seconds, it'll push it out, and then it will retreat itself, and then it'll start all over again.
What I put first, other color that now is yellows, and then I'm going to put the yellows.
Hopefully, it works with the timer. Like Garda said, it's a yes or no type of thing. So we try to try to be as precise as possible. We did at 2.5. Like we did many trials, and it actually worked. So hopefully everything goes well.
Okay.
He's turning on the motor independently.
You see?
See, with the yellow, and then the other colors, they just pass through down the conveyor belt.
Yeah, the speed of the conveyor is very important. Because 2.46 is, the time is exactly. The time is space also. This is why.
Why is yellow open?
What happened to that yellow there? It's like ego.
I think at that point, I think
Before the speed for the conveyor. So if the speed is not continually the same speed, you lost time.
So that thing is programmed to have a certain object passing at certain intervals.
Yeah, like he said, like I don't know if you listen what the Garda said.
So you can't put like
Yeah, in this case, we wouldn't be able to put like one by one, like as in a row.
Now
It's just a demonstration.
Okay.
Yeah.
But like he said, he has like a 2-second delay when he reaches the first one, and he has to reboot the next one.
Yeah, when he passes here, it's 2.5 seconds through here. And then, when pass here, there
2
is
seconds again to retrieve the
and then,
To
go to reset. Yeah,
and
make
it
it
restarts again.
look.
So see, it's just a demonstration. You wouldn't be able to put like all the colors at a time.
You should put the LED. Anytime the 2 seconds pass, and then the LED flash. You told
Yeah.
you 2 seconds is that, and then put another object.
Yeah, no, I mean the like you said, we can improve a lot on the project. It's just a demonstration.
But in that case, we had to work with a better conveyor, because we can. In that case, you can put the operator closer to the sensor, less time, and then work more continuously.
We're trying to do it a better, more complex project with three actuators. So you would see like with 3 different colors, and it would actually like separate it. Like you would see more like as a factory, like I was trying to explain, with 3 actuators, it would be better. You would see a more complex demonstration.
What about the speed of that? The speed of the death is like low.
Yeah, because
It's more like a mechanical problem, not.
Yeah, it's mechanical. It's nothing. It doesn't have to do with the sensor. The sensor and the time is they work fine.
Like a domestic.
The belt is not. We don't have like precise measurements to keep everything like tight down
What
to the
type of
second.
fail-safe device could you guys implement on that thing?
What do you mean like a fail-safe?
Like say you have this in full production, okay? And it's going through. What happens when the system stops working and it's just shooting things out?
Usually everything has a kill switch, just like the ones we have here, but it'll be the same thing. If something starts getting stuck or something, all things have a kill switch. You just go and everything shuts down.
Do you have that?
Yeah, we have 2 switches which work. Like that one, like shuts the motor off independently, and this one turns the PLC.
You turn off, you reset everything.
yeah.
So if one switch is set off, the entire machine won't work.
Usually we like I said, we divide it into 2, but yeah, there's usually a 1 kill switch which turns everything off. Okay, so if you want to go ahead and check it out behind, so you can see everything that we explained. Like
Can we have a group picture?
I'm not going to have a group. Show the POs.
Ya habla así si quieres.
No, para que le dé vuelta. Para que le firme.
Dale vuelta para acá. Dale vuelta completa.
What they want to do
The PLC, the switch, the motor.
That's good, that's it, yeah. The motor and everything.
Derecho, right? That's cool.
That's, yeah. Okay. Yeah, come take group pictures. Come on. Yes.
Una foto de grupo.
Tell that. Come on, take this.
Still wants the picture with you know, everyone.
Oh, I don't do pictures.
Come
I
on.
don't do pictures.
You gotta do this time.
I don't want proof. I don't see it.
Come on, it's okay. Come on.
I'll show you the belt. This is just like, we want to present materials to like.
Come on, join us.
Lo que
Every
pasa
time it
es...
rolls for like a millisecond, that's why sometimes it won't read it. It's not flowing like steady. You know, but it's like just a constant.